Welcome to SSR Pharma Media, your trusted source for pharma knowledge. Pharmaceutical Inorganic Chemistry MCQ series, your exam power boost. So, in this PIC, Pharmaceutical Inorganic Chemistry, today we are going to discuss about limit test part 1. Prepare, practice, succeed. So, in the limit test, today we are going to cover limit test introduction, limit test for chloride, limit test for sulfate, limit test for iron, limit test for heavy metal, limit test for lead. So it is part 1. Today we are going to cover. And next video we will cover part 2, limit test for arsenic and modified limit test for chloride and sulfate. So let me discuss about what is limit test. So limit test is a semi-quantitative analysis carried out to find out the extent of impurity present in the given sample. So semi-quantitative test designed to identify, control small quantities of impurities that may be present in pharmaceutical substance. So it ensures that impurity level does not exceed the prescribed pharmacopoeial limit. So this is called limit test. So next move to the question. The limit test used in pharmaceutical analysis is an example of which type of analytical method? So the answer is option C. It's a semi-quantitative analysis. So limit test is a semi-quantitative analysis. It's mainly used to find out the extent of impurity present in the given sample. Which of the following apparatus is commonly used in performing various limit tests specified in the Indian Pharmacopoeia? So the answer is option A, Nessler's cylinder. So Nessler cylinder is the answer. So here Hazel flask is used to estimate the nitrogen. Calorimeter is used to quantitative color measurement. Conductivity cell is used for the measuring ionic conductivity of solution. So limit test for chloride we will discuss, and chloride is the impurity, and for identifying the chloride we need the reagent silver nitrate and medium nitric acid, dilute nitric acid, and observations turbidity or opalescence due to formation of AgCl, and pass criteria is test is less than that of the standard. That means test turbidity or opalescence less than that of the standard. So reagent, purpose of reagent and medium used in the limit test for chloride. So AgNO3 is the reagent, nitric acid, silver nitrate is the reagent. So reacts with the chloride ions to form insoluble silver chloride. So this silver chloride makes the solution turbid or opalescence. And nitric acid acidifies the solutions and prevent the interference from carbonate and other phosphate ions that might form insoluble salts with silver. So in order to prevent this, we are adding dilute nitric acid or using as a medium. This is the reactions. Soluble chloride reacts with the silver nitrate to form silver chloride precipitate. So this is a comparison. So test is less than that of the standard. So this is the standard. Sorry, this is one is the standard. So test is less than that of the standard means it's a pass. So more than that of standard leads fails. Question: the reagent used in the limit test for chloride is? So answer option B, silver nitrate. So silver nitrate reacts with the chloride ion to form insoluble white turbidity of chloride ion, silver chloride precipitate. What is the medium used in the limit test for chloride? So the answer is option C, nitric acid. So dilute nitric acid acidifies the solutions and prevent the interference from the carbonates and phosphates. The observation in the limit test for chloride is, so the answer is white turbidity. The formation of white turbidity due to formation of silver chloride precipitate confirms the presence of chlorides. The principle of the chloride limit test is based on formation of, so the answer is option B, insoluble silver chloride precipitate. So Ag and silver ion from silver nitrate react with the soluble chloride from the sample or sample solution to form insoluble silver chloride turbidity. What is the pass criterion for the limit test for chloride? So the answer is option C. The test turbidity is less than that of the standard turbidity. So test turbidity of the test should not exceed that of the standard solution. Why nitric acid is used in the limit test for chloride? So the answer is option C. So to prevent the interference from the carbonate or phosphate. So it maintains the acidic pH and prevent the formation of other silver salts. So in acidic conditions, prevent the precipitation of other silver salt like silver carbonate and silver hydroxide that could form a neutral or basic solution. So unlike hydrochloric acid and nitric acid is free from chloride impurities. So it does not contribute extra chloride ion that could give a false positive results. The chloride standard solutions for limit test ppm of chloride ion. So option B, 25 ppm of the standard chloride solutions is used for the test of the limit test for chloride. So next is the limit test for sulfate. So limit test for sulfate, for detecting the sulfate impurity, need reagent barium chloride reagent and medium hydrochloric acid. Then observation is turbidity or opalescence due to formation of barium sulfate. And pass criteria, test solution is less than that of the standard solution. And this purpose of reagent and mediums are used. So barium chloride is react with a soluble sulfate ion to form insoluble barium sulfate to make the solution turbidity. And HCl provides an acidic medium to prevent precipitation of barium carbonate or phosphate, ensuring specificity for sulfate ion. The barium chloride test solution in IP has been replaced by barium sulfate reagent. Barium chloride, in that barium chloride reagent, there are three reagents are there: barium chloride, sulfate free alcohol and potassium sulfate. So in that barium sulfate reagent, barium chloride is acting as a seeding agent for the precipitation of barium sulfate if sulfate present in the substance under the test. Sulfate free alcohol is used in this barium sulfate reagent to prevent precipitation supersaturations and produce uniform opalescence or turbidity, and prevent external sulfate contaminations and ensures the clarity. And potassium sulfate used in this reagent increases sensitivity by forming fine barium sulfate nuclei. And standard sulfate solutions for limit test chloride is 10 ppm. So limit test for sulfate. Standard sulfate solution for limit test for sulfate is 10 ppm. So which of the following reaction represent the principle of the test? So the answer is option C. Soluble sulfate react with barium ion to form insoluble barium sulfate precipitation. This formation of barium sulfate precipitation make the turbidity of the solution. In the barium chloride test for sulfate ions, why is HCl added to the reaction mixture? So the answer is option B, to prevent precipitation of barium carbonate or phosphate. So HCl provides an acidic medium that prevent the formation of barium salts like barium carbonate or barium phosphate. So ensuring that the turbidity formed is due to only to barium sulfate, thus improving specificity of the test for sulfate ions. So in the current Indian pharmacopoeia, the barium chloride test solution has been replaced by which of the following? So the answer is option B, barium sulfate reagent. So in Indian pharmacopoeia, barium chloride test solution is replaced with barium sulfate reagent, which offers greater sensitivity and better control of ionic concentration of sulfate detection. Barium sulfate reagent, as described in the Indian pharmacopoeia, contains which of the following component? So the answer is option B. So barium sulfate reagent contains barium chloride, sulfate-free alcohol, potassium sulfate and hydrochloric acid. So barium sulfate reagent, barium chloride acts as a seeding agent for the precipitation of barium sulfate. Sulfate-free alcohols to use to prevent the supersaturation and produce uniform opalescence or turbidity and prevent the external sulfate contaminations and ensure the clarity. Potassium sulfate is increase the sensitivity by forming barium sulfate nuclei. Match the following concepts and principle with description. So first is the replacement of barium chloride solution with barium sulfate. So the answer is barium sulfate replacing with the, so first answer is option A. So A is the first, is the ensure uniform and reproducible sulfate detection. So an acidic medium HCl is used for the prevention of precipitation of barium carbonate and barium phosphate. And sulfate, addition of sulfate is to enhance the sensitivity through controlled seeding. And slightly exceeded potassium sulfate of barium sulfate promote the nucleation of barium sulfate particles. Leaching of plasticizer or dyes into the formulation from containers represents, so option A, packing impurities. So packing material can leach impurities, especially from PVC or colored plastics. The standard sulfate standard solution for limit test dash ppm sulfate ions. So the answer is 10 ppm sulfate ions. So next is a limit test for iron. So in limit test for ions, these are reactions. So first is a ferric ion reduced under the presence of thioglycolic acid to form ferrous sulfate, and this ferrous sulfate again react with thioglycolic acid to form ferrous thioglycolate, is a pink color complex. And in thioglycolic acid reacts with the ferric ion in the presence of citric acid and ammonia, produce pale pink to form deep reddish purple color. So it is formed ferrous thioglycolate complex, and it is a type of coordination compound. And thioglycolic acids act as a reducing agent to reduce ferric ion to ferrous ion, the first reaction. And ammonia provides alkaline medium. Ferrous thioglycolate complex is colorless in acidic or neutral. So the color develops in the presence of alkaline medium only. Iron-free citric acid is used in the limit test for iron to facilitate the formation of ferrous ion and form complex with iron and prevent its precipitation by ammonia. Iron standard solution for limit test for iron is 20 ppm. Then observation, the intensity, color intensity is produced in the test solution should less than that of standard in order to pass. So the color intensity of test is compared with the standard solution. In the limit test for iron, thioglycolic acid is used because of it. So option A is the answer. Act as an oxidizing agent. So thioglycolic acid reduce ferric ion to ferrous ion. The ferrous ion then react to form deep reddish purple ferrous thioglycolate complex in alkaline medium. The role of citric in the limit test for iron is to, so the answer is option C, prevent precipitation of iron by ammonia. So citric acid forms complex with iron, preventing its precipitation as ferric hydroxide in alkaline conditions. It ensures iron remains in solution for proper color development. In the limit test for iron, the deep reddish purple color appears only in alkaline medium. So ferrous thiocalculate complex is colorless in acidic and neutral medium, but develop purple color in alkaline medium by ammonia. The function of ammonia in the iron limit test is to option B is the answer, provide alkaline medium for color development, because in alkaline pH only the ferrous thiocalculate develops the deep reddish purple color. So it is the ferrous thiocalculate complex. The purple coloration observed in the iron limit test indicate the formation of, so the answer is option B, ferrous thiocalculate complex. The standard iron solution used in the limit test for iron correspond to 20 ppm. So 20 ppm standard iron solution. Next, the limit test for heavy metal. So for detecting the heavy metal impurities, you need the reagent hydrogen sulfide and thioacetamide reagent. The medium's acetate buffer, the pH is 3. Observations, brown or black coloration of precipitate is formed due to the formation of corresponding sulfides like lead sulfide or mercury sulfide, and test is less than that of the standard color. So in this limit test for heavy metal, reagent use purpose is hydrogen sulfide is used, react with heavy metal ions to form colored sulfide precipitate, so brown to black color. Then acetate buffer maintain a slightly acidic pH to allow controlled sulfide precipitation while avoiding interference from other cations. And lead standard solution for limit test. So there is the method A, B, C. So in this 3 method 20 ppm, method D 1 to 2 ppm standard solution is required. And method A used for the substance give clear colorless solution. Method B is used for the substance which do not give clear colorless solution, may contain lot of organic matter, and sample taken in a crucible and the organic matter destroyed by addition of nitric acid or sulfuric acid, and ignition at 500 to 600 degrees Celsius in muffle furnace. Residue is digested with HCl, then pH 3 to 4 using acetate. Method C used for the substance which give clear colorless solution when they are dissolved in NaOH solution while precipitation of metallic sulfide carried out in method A and B, moderately acidic conditions. So method C in alkaline condition. Method D so used for certain substance in which other impurities or drug itself may interfere with usual sulfide test. Thioacetamide reagent pH is at 3.5. So in the limit test for lead, hydrogen sulfide react with heavy metals ion such as lead to form, so option C, metal sulfides. Hydrogen sulfide react with heavy metal like lead, copper, mercury to produce colored sulfides corresponding metal sulfides such as lead sulfide. Its color is brown to black color. The acetate buffer used in the limit test for lead maintains a pH around 3 to, so option C, maintain slightly acidic conditions for controlled sulfide precipitation. The standard lead solution concentration used in limit test method A, B, C is, so option B, 20 ppm, and method D is the 1 to 2 ppm. The method B limit test for lead is specifically used for, so option B, substance containing organic matter that causes turbidity. The main difference between method A and method C of the limit test for lead is, so option A is the answer. The method C is performed in alkaline medium while method A in slightly acidic medium. Method D in the limit test for lead is preferred when, option B is the answer, when the drug or impurities interfere with the usual sulfide precipitation test. So in method D, standard solution 1 to 2 ppm lead standard is used. So next is the limit test for heavy metal. So in limit test for heavy metal, also called as diphenyl thiocarbazone test or dithiazone test or method. So in dithiazone means diphenyl thiocarbazone method is used on the formation of colored complex between lead ion and dithiazone in alkaline medium. So dithiazone react with lead to form lead dithiazone complex, which is violet in color and soluble in chloroform. The intensity of color developed is proportional to the amount of lead present. If the color intensity of the test solution is not deeper than that of the standard, the sample passes the limit test for lead. So this is the reaction dithiazone structure and react with the lead ion in the presence of alkaline medium to form lead dithiazone complex. So this color of this complex is the violet color. So observation, the chloroform layer of the test solution show no deeper color than the standard. And interpretation, the sample passes the test solution. The chloroform layer of the test solution is deeper pink or red than standard. The sample fails the limit test. Color of complex is violet color because of the formation of lead dithiazone complex in chloroform solution. So keynote, the test is very sensitive, detecting lead in ppm level. So usually 1 ppm. Care must be taken to avoid contamination from glasswares or water containing trace of lead. Dithiazone reagent is sensitive to light and oxidation, should be freshly prepared and stored in dark bottles. So next is the reagent used. So dithiazone solution, diphenyl thiocarbazone. So purpose of this reagent is act as a color reagent, forms colored complex with lead, usually prepared in chloroform. And standard lead solution contain known quantity of lead. So usually 1 ppm for comparison. And ammonium citrate added in this test form soluble complex with interfering metal ions and preventing interferences. Hydroxylation, hydroxylamine hydrochloride solution acts as a reducing agent, reduces ferrous ion into ferric ion into ferrous ion to prevent interferences. And potassium cyanide solution and purpose complex with metals like copper and preventing them from reacting with dithiazone. So used with caution, it is toxic. Buffer solution nearly pH 7, maintain alkaline pH required for proper color formation. Chloroform, the solvent to extract the lead dithiazone complex. The color is absorbed in the chloroform layer. Dilute nitric acid is used. So used to acidify the sample and dissolve lead if present in soluble form and converts all lead dithiazonate into lead nitrate. The principle of the dithiazone method for lead limit test is based on the formation of, so the answer is option B, a colored complex between lead and dithiazone in alkaline medium, which is the violet color in red color in the pink to red color. This is pink to red color. The color of the lead dithiazone complex formed in the dithiazone method is, so option C is a violet color. So lead dithiazone complex extracted into chloroform exhibit violet coloration. So the intensity of which is directly proportional to the amount of lead present in the sample. So when in chloroform, so the color is red color. When lead dithesone complex is formed, its color is violet color. In dithesone method, the reagent acts as a coloring reagent. So option B, diphenyl thiocarbazone solution. What is the role of ammonium citrate solution in dithesone test? So the answer is option C, complexes interfering metal ions like ferrous and copper. The function of hydroxylamine hydrochloride in the dithesone method is to option B, reduces ferrous to ferric ions. The dithesone method requires a buffer of pH around 9 to. So the answer is option B, maintain alkaline conditions for complex formation. In dithesone limit test, which solvent is used to extract the lead dithesone complex for color comparison? So answer is option C, chloroform. So lead dithesone complex is soluble in chloroform and chloroform layer shows pink or red color, which compared usually with the standard lead solution. What is the role of dilute nitric acid in dithesone limit test for lead? So the answer is option B, to dissolve lead compounds and acidifying the samples. The reagent used in the limit test is lead limit test is. So answer in the comment box. So join in our WhatsApp community. You will get the hands-out material and future number of test series in order to succeed. So thank you. Like, subscribe and share.